Alrighty. So, we already did some composition. You guys are being recorded right now. So we've already done some composition. Let's just refresh. Composition means you're putting one function in and then evaluating another function based on its output. And this means I start with the inside and work out. Okay? Normally keep in mind that if a function, you take the composite of its inverse. Normally we talked about how you get x back, correct? So inverse functions would be cos and cos inverse, sine and sine inverse, tan and tan inverse. There's one little exception though, you're going to see here. Normally these things should just cancel one another out and I get 5/3. But because of the range restriction on cosine inverse, we're going to get a different answer, okay? Alright, so first of all, can somebody tell me what's the arctan of -√3? We just did this one. At what angle is the tangent -√3? Very nice, -5/3. Then, what is the sine of -5/3? -√3/2. Okay. So, this is where, because of the restriction, remember how arc cosine is only a range of 0 to pi? Do you see how 5/3 is outside of that? So what ends up happening here is we're going to do the cosine of 5/3. On the unit circle, 5/3 is in quadrant 4. What's the cosine there? 1/2, very nice. The cosine inverse of 1/2. Now, if you look on the unit circle, yes, 5/3 produces a value of 1/2. But cosine inverse, I only give the value where? Between 0 and pi. So between 0 and pi, where is the cosine 1/2? Positive pi/3. Okay. Very nice. Now, how about if it's in general? And the first thing I'm going to tell you is this, guys. If today you see this, the sine of the sine inverse of x, this is just x. A sine and a sine inverse should undo one another. Or if I say to you, hey, what's the sine of the sine inverse of, I'm going to make something up, 0.8. It should be 0.8 because the definition of an inverse is they undo one another. Okay, however, that's x and an x. If I ask for a different trig function, we use this kind of triangle, SOHCAHTOA idea to figure this out, okay? So remember how I said that an inverse function outputs an angle, right? So what I'm going to do is I'm going to say, okay, so this cosine inverse, that's going to output an angle. And so what I'm going to do is I'm going to draw a triangle, a right triangle, and I'm going to put a theta in the corner, okay? In order for this triangle to work, according to what I asked you to do in A, theta has to be equal to the cosine inverse of x. What that means is the cosine has to be x. What's cosine the ratio of? Alright, if I put an x in the adjacent and a 1 in the hypotenuse, wouldn't the adjacent over hypotenuse be equal to x? Okay, and so what we do is we make a triangle and we make an angle such that that's true. Now, then we evaluate the trig function. So now I want to evaluate sine. So what is sine the ratio of? Opposite over hypotenuse. Well, shoot, what's the problem with that? there's no opposite. So what I'm going to do is I'm going to write an expression for the opposite using Pythagorean theorem. This squared plus this squared equals 1 squared. Agreed? So this leg should be 1 squared minus x squared, take the square root. And we're going to leave it like that. This is just an expression in terms of x. We can't get it exactly, but now we know sine, so sine of theta is opposite, which is the square root of 1 minus x squared, over hypotenuse, which is 1. So you don't have to write the 1 down if you don't want. All right. Now, this is, you can do this with any expression. I just did it with an x. You could do it with a 2x. You could do it with an x and a 2. So I'm going to show you a second what it would look like if the sine inverse was 2x. Okay? So I'm going to make this theta because we've agreed sine inverse should output an angle. I'm going to draw a triangle. In order for this statement to be true in this triangle, what does this mean? That the sine should be what? Is it x anymore? It's 2x, isn't it? Okay. So what I'm going to do now is I'm going to use the same idea. Sine is opposite over hypotenuse. So I'm going to make the opposite 2x, the hypotenuse 1. Because isn't 2x divided by 1 2x? Same idea as before. Let's reverse Pythagorean theorem. So it's going to be 1 squared minus 2x squared. But hold on, folks. What's 2x squared? What is that? Isn't that 4x squared? Okay, just so you're understanding where this is coming from. This side squared minus this side squared, that's an expression for the other leg. And finally, I want the cotangent. So cotangent is the reciprocal of tangent. So tangent is opposite over adjacent. Cotangent is adjacent over opposite. So the cotangent of theta is going to be the square root of 1 minus 4x squared over 2x. Yes.